Hello, everyone. My name is Yu Minrui. It's a great honor for me to present our work, in-hand following of deformable linear objects using dexterous fingers with tactile sensing. Deformable linear objects, which are called DLOs in short, refer to the deformable objects with one-dimensional shape, such as ropes and cables. Most of the existing studies assume rigid grasp, such as fixedly grasping the two DL ends in our previous works. However, humans usually do not manipulate DLOs entirely relying on rigid grasp and regrasp, but involving some dexterous in-hand actions. DLO following is a typical in-hand manipulation skill. In DLO following, the robot needs to continuously change the grasp point by in-hand sliding while holding the DLO to prevent it from falling. Using specially designed end-effectors will lose the versatility on manipulating other objects. Some work has tried using generic parallel gripper. However, it is difficult for parallel grippers to find a proper gripping force to balance the following and holding. Let's think about how humans achieve this task. Utilizing the dexterity of fingers, humans usually form the two fingers as a V shape, which ensures holding the DLO without applying large contact forces to the DLO. In this work, we aim to imitate such human skills by a generic dexterous hand with tactile sensing. We built a hardware system including a robot arm, a lip hand, and two geosite mini tactile sensors mounted on the two fingertips. To enable the hardware to function in the real world, we developed an algorithm framework including control of the arm-hand system, tactile estimation of in-hand DLO poses, and motion design for DLO following. We developed an optimization-based multi-objective inverse kinematic solver for Cartesian space control of the arm-hand system. Different with the previous 2D pose estimation approaches, we developed an optimization-based in-hand 3D pose estimation method. Based on the control and perception approaches, we designed the simple but effective V-shaped robot motions. Additionally, we adopt a page controller to adjust the orientation of the fingers to match the in-hand 3D DL poses. The experimental results demonstrate that our method is much more robust than using parallel grippers. We test the generalizability of our method to different DLOs and different following speeds. This case showed the comparison between whether using tactile feedback. When not adjusting the finger's orientation according to the estimated in-hand poses, the two fingers will easily become misaligned due to the DLO tension forces. We also conduct a simplified cable routing task. It demonstrates the ability of our approach to switch between rigid grasp and following, which is an essential skill in high-level tasks. In conclusion, we explored the usage of a dexterous hand with tactile sensing to enhance the in-hand DLO following. Thank you for your listening.